I should have had my tablet up and running, but let's take a look at this. So let's get my tablet up in the calculator. And there it goes. Okay, so the delivery time for a package sent within the United States is normally distributed with a mean of 4. So mean is 4. And a standard deviation of approximately 1 day. So sigma is 1. Now the reason I say mu and sigma is because nowhere does it refer to a sample, so it has to be those. If 300 packages are being sent, how many packages will arrive in less than 3 days? Now this one's a little bit tricky, and everybody's going to get credit on this one because I don't like how it's really set up. But what we need to do is find the probability that it'll arrive in less than 3 days. So here we got x is equal to 3, and less than is shaded this way. So we're going to do normal CDF, and clear over here is negative E99. Because your shaded region, if it goes to the left, it's always negative E99, which is equivalent to negative infinity. And then 3, and then our mean, and then our standard deviation. Okay, so I'll do second vars, normal CDF, negative E99, comma, 3, comma 4, comma 1. And we get this for our probability. So that's going to give us 0.1587, 4 decimal places. But what they're asking about is if 300 packages are being sent. So we need to multiply this by 300 and see how many that equals. It's already in my calculator, so I do times 300. And that would give us, rounding, 48. Okay. Let's take a look at this next one. Let's see. Let x be a random variable that represents the length of time it takes students to complete a take-home exam in Dr. Larson's psychology class. After interviewing many students, has found x is approximately a normal distribution with a mean of 5.2. So mu is 5.2 and standard deviation 1.8. So sigma is 1.8. Convert the initial x interval, x is greater than or equal to standard z. Oh, that's interesting. So x is greater than or equal to 9.7. Well, our formula is z is equal to x minus mu over sigma. So we're going to plug in x, which is 9.7. That'll be whatever values right here. Minus mu, which is 5.2, divided by sigma, which is 1.8. Now, if you have more than a single number or single anything on top or bottom of a fraction, when you plug in your calculator, you have to put parentheses around that part. So I'm going to do a beginning parentheses, 9.7 minus 5.2, close parentheses, divided by 1.8. And that gives us 2.5. Which means that this right here, the x is greater than or equal to, becomes z is greater than or equal to 2.5. The inequality symbol remains as is, and we just plug in our new value. Okay, so z is greater than or equal to 2.5. Here it is. Z is greater than or equal to 2.5. Okay, 3. Let x be a random variable that represents the length of times takes to complete the... Okay, same wording. After interviewing many students, found x is approximately normal with a mean of 5.2. So sigma is 5.2 and a standard deviation of 1.8 hours. Okay, so that's the same. Convert the z value. Z is greater than 1.5. So z is greater than negative 1.5. I guess I should read closer. And z is less than 1 to a raw score x interval. Okay, so z is greater than that, and z is less than 1. Okay. Now this is using the same formula, we're just going in reverse. So what I could do is I could solve this for x, and that'd make my life a little bit easier. So if I got z is equal to x minus mu over sigma, I can multiply both sides by sigma. So we got z times sigma is equal to x minus mu. Take the negative mu over, and we get mu plus z alpha, or z sigma, is equal to x. Okay, so that's the formula we use. So for this x value, mu was 5.2 plus z. Z is negative 1.5, so I'll say a negative 1.5 times sigma, which was 1.8. And for this x value, we're going to have, again, our mean, which is 5.2, and then plus z. This time z is 1. Z is whatever number's on the right side here, times sigma, which was 1.8. Let's see what that gives us. 5.2 minus 1.5 times 1.8, 2.5. Did I plug that in right? Okay, yeah, I did. And this one gives us, oh, I shouldn't have plugged that one in the calculator. 7? Yeah, 7. Okay, so now this is a greater than, so this should be a greater than. So this is x is greater than 2.5, and x is less than 7. Now, I don't know if that's how they'll write it, but let's see. X is greater than or equal. Did I forget the equal? No. Greater than, or equal. Is greater than 2.5 and less than, okay, well, it'd be this one. Okay, number 4. Lifetime of a super tough AAA battery's normally distributed with a mean of 28.5. So sigma is 28.5 and a standard deviation of 5.3. So, or mu is 28.5 and sigma is 5.3. For a battery selected at random, what is probably the lifetime will be 25 hours or less. Now we're talking about one battery, because it says what's probably that, or for a battery, and 25 hours or less. So this is 25 and shaded this way. So this is going to be normal CDF, negative E99, comma, 25. You put your low value. This is based upon your shaded region. So your low value, comma, your high value, comma, your mean, comma, the standard deviation. So let's see what that gives us. Second vars, normal CDF, negative E99, comma, 25, comma, 28.5, comma, 5.3. And 0.2545, 0.25. It's closest to this. You'll find that if you do these by hand versus on a calculator, you'll have it come out slightly different like that. Okay, number 5. Let's see. Lifetime, same setup looks like. Mean is 28.5, so that hasn't changed. Sigma is 5.3. That hasn't changed. For a battery selector, what's probably lifetime would be 34 hours or less for a battery. So 34 phone's ringing, so I'm sitting here thinking about that. 34 or more is shaded to the right. So this will be E99. So we'll do our normal CDF, our low value, our high value, our mean, and then our standard deviation. So let's see what that gives us. We got our normal CDF, 34, comma, E99, comma, 28.5, comma, 5.3. 0.1497, 0.1497. Again, taking into account the differences, this is the one that's closest. It's frustrating when you got problems dealing with technology and by hand, since they do come up with slightly different answers. Our answer is actually more accurate, but when you're using the when you're doing it by hand using tables, it's not as precise. Okay, number 6. Same wording. Will be between 25 and 34. So 25 and 34, and we're shading this way. So we'll do our normal CDF. We'll do 25, comma, 34, comma, our mean, which is still 28.5, comma, our standard deviation, which is 5.3. Okay, so second vars, normal CDF, and we got 25, comma, 34, comma, 28.5, comma, 5.3. And that gives us 0.5958. 0.5958, so this is the closest one. Okay, number 7. Quality control studies for dependable dishwasher, so the lifetime follows normal distribution with a mean of 8 and a standard deviation of 1.2. Company will replace any dishwasher that fails during the guarantee period. How long should the company's dishwasher be guaranteed if the company wishes to replace no more than 2%? Okay, now let me think about this. Follows a normal distribution of the mean of 8 and standard deviation of 1.2. Company will replace it into the fails during the guarantee period. How long should the company dishwashers be guaranteed if the company wishes to replace no more than 2% of the dishwashers? This is based upon mean of 8, how long it lasts. So this is the lifetime. And when they say they want to replace no more than 2%, they're telling us the 0.02% is going to be over here. So this will give us the value where 2% of them will fail. Now this is INV norm, and INV norm was always based upon the area left, which will be 0.02, comma our mean, comma our standard deviation. So do second vars, choose INV norm, 0.02, comma 8, comma 1.2. Then we get 5.54. Of course, I don't know what it's rounding to. 5.5. Okay, that's just a definition. Number 9. Records show that 29% of all payments to a mail order company are submitted after the due date. Suppose 50 payments are submitted this week. Let R be the random variable that represents the number of payments that are late. Use a normal approximation of the binomial to estimate the probability that R is greater than or equal to 20 and that R is less than or equal to 25. R is greater than or equal to 20 and R is less than or equal to 25. Greater than or equal to 20. Okay, so it's asking about this right here. And, if I can remember where the steps are. It'll be the big question. And, unfortunately, my computer's kind of slow. I guessed right. Okay. It says records show that 29% of all payments, so P is 0.29. Suppose 50 payments are submitted, so N is 50. I guess that's it. So then this is X, and this is X. And going through our steps, we need to find the mean and standard deviation. So mu sub P hat is equal to P, which is 0.29. And sigma sub P hat is going to equal to square root of P, which is 0.29, times 1 minus P, so 1 minus 0.29, divided by N, which would be 50. Okay, so I got square root of 0.29, 1 minus 0.29, divided by 50. It's probably going to be a long number. I don't want to sit there and type in over and over on each one of these problems. I'll write it down. 0.0641716,448. But I'm going to store that. So I'm going to press my STO button. And I'll put in an X just because that's easy. And then press enter. Okay, so whenever I want this number in a calculation, I just have to put X in there. Okay, so now we need to convert these to z-scores, because currently these are x values. So for x equals 20, we're going to have z is equal to p hat. Now p hat is x over n. So actually, before I do that, let me put that in a separate calculation. The p hat here will be x over n, which will be 20 over 50, which is 2/5. Thought I had a calculator here. Oh well, I'll leave it as 2/5. Well, actually, is that 0.4? 0.4. And now that I have that, then I can plug in this formula. So we get z is equal to p hat, which is 0.4, minus mu sub p hat, which is 0.29, over sigma sub p hat, which remember we put in x. Now when we plug this in, we want to put parentheses on the top part. So I'll put parentheses and then 0.4 minus 0.29, close parentheses, divided by x, and then press enter. Now, I would probably recommend taking these to 2 decimal places to get it to match the answer you get by hand. more decimal places would actually be more accurate. And we need to do the same thing for the 25. So we got our p hat is equal to x over n. So we got 25 over 50, which is 1/2 or 0.5. Then our z will have 0.5 minus mu sub p hat, which is 0.29, divided by sigma sub p hat, which we stored in x. So I do beginning parentheses, 0.5 minus 0.29, close parentheses, divided by, and x is where we stored that, and then press enter. And we got 3.27. Now our picture says we're going between 1.71 and 3.27, but these are z values. So that's z equals, and this is z equals. So our last step, since it's between two values, we're going to use this normal CDF. So we'll do normal CDF, 1.71 comma 3.27, and then you always put 0 and 1 when you're talking about z values. If you leave those off, they actually default to them. Okay, so we got normal CDF of 1.71 comma 3.27 comma 0 comma 1 and 0.0431 0.0431 matches exactly. It wouldn't have if I hadn't rounded those to 2 decimal places for the z-scores. Okay, number 10. It says the height of 18-year-old men are normally distributed with a mean of 68, so mu is 68, and sigma is 3. And if a random sample of 9 18-year-old men is selected, what is probably that the mean height is between 67 and 69? So 67 to 69. And we're talking about mean height, and we're talking about those 9 individuals. So we're talking about more than one, which means we're going to use normal CDF. This is central limit theorem. And we'll do 67, comma 69, comma our mean, which is 3, comma our, wait a minute, eyes are off. Mean is 68. And then comma our standard deviation, which is 3, divided by the square root of n. Okay, so let's see what that gives us. Second vars, normal CDF, 67, comma, 69, comma, 68, comma, 3 divided by square root of 9, which is actually gives us 1, but go ahead and put it in there. 0.6827. 0.6826. That's the closest one. So that'd be the overview of how to do those problems on this test.